All right, so hopefully we can start on time. There'll probably be a few more troublemakers coming in the back. Welcome, welcome. For this talk today, I'm going to walk you through some of Electron's internals and show you some stuff under the hood and ultimately what makes it tick. Out of curiosity, who here is using Electron at the moment? I've got one hand up the back, so lots of people aren't. Excellent, excellent. I'll keep that in mind. So for those of you who don't know me, my name is Brendan Forster. I work at GitHub engineering under the client apps team, and I've been spending the last few months with Electron. Previously, I was a .NET dev doing WPF. So probably the first thing to cover off around the stuff is you probably got a lot of questions about Electron, seeing how I only saw one hand for the talk. You know, what is this thing? Why should I use it over blah? What should I use inside an Electron app? This is not that talk. I hate to be the bearer of bad news, but there are lots of other things out there to look at for those resources, and I wanted to put up this talk mostly for fun. There was a talk yesterday at the conference by Christian and Mahesh talking about the why and the how for building out Electron apps, so I recommend you guys look at that. So this talk, we'll be diving into what makes up Electron, the various bits and pieces that are there, what happens when the Electron app runs up, how it plugs into your app, and how you get to the stuff underneath, and a little bit about the packaging at the end. This is where I rant a little bit about the magic of the frameworks that we use. I love kind of understanding what's going on underneath because at some point in time, you will need to go underneath and understand what's actually happening when your frameworks are running. Oh, I didn't put it on repeat. Anyway, you get the idea. The other part about wanting to do this talk was all of the stuff that's Electron related is open source. And so I'm just going to walk you guys through the stuff that's there and show you guys where to find stuff if you want to dig deeper into Electron. So I did not start my timer. So before we dive into the source code, I want to give you some backstory on Electron and how it came to be. So you might have heard of Atom, the editor that GitHub put out. It was a while ago, February 2014. We published it out as a private beta, and then we open sourced it a couple of months later. But the history on this actually goes back a bit further. So fearless leader of GitHub and current CEO Chris Wanstrath was back in 2008 experimenting with using web technologies in a desktop scenario. He was inspired by Emacs and the crazy extensibility stuff that's there, but he didn't want to write stuff in Lisp. And so he built something out with WebKit and JavaScript behind the scenes to kind of prove out this idea. But unfortunately, one of his other little ideas that became GitHub took off. And so this thing sat around for a while until he came back to it and hired some other people to do the job. And the stuff that was in this project that was called Atomicity became Atom. And so when we published that out, we got a lot of interest from people doing other stuff to the point where the core of it, what was called Atom Shell at the time, deserved to be its own project in its own right. And so about 18 months ago, Atom Shell was renamed to indicate that it was a standalone thing. And so since then, we've had Microsoft come to the party and use it for Visual Studio Code. We've had Slack do it for their chat apps, Brave, the browser, using Electron. All these other people are building stuff on top of it. So it's been a really lovely, wonderful journey. So it went 1.0 back in April. We had a big announcement to say, like, this is our point where we're going to do some API stability and build on that one from there. And ultimately, there is a lovely website called electron.atom.io. If you want to go find some more resources, there's a lovely introductory stuff and documentation there. And that's where we're going to start. So just flipping my mouse around, just merge. Arrangement, mirror. Cool. So electron.atom.io. So the current version is 1.3.2, and we call out some very important components, Node, Chromium, and V8. For those of you who are probably familiar with Node, it's a framework written for doing JavaScript and traditionally for server-side apps. But we use this thing locally to kind of let you guys do desktop apps using JavaScript. Chromium itself has a whole sorted story, which I'll explain in a little bit. And then there's this thing, V8, the JavaScript engine that's in Chrome. So these components are all important to what makes up Electron. And so I'll walk you through how we actually package up Electron and explain all the components. So like all good things, the Electron release starts from a Chrome release. So the Chrome team has their stable, canary, beta channels, and they will announce stuff fairly frequently. So this was from a couple of days ago. The one I'm looking for quite often is the stable channel. So on Wednesday, they publish up a new version of the stable channel. We go, cool, all right, now it's time to look at upgrading Electron. The big problem with this stuff is that they don't make it easy for us to consume the source code. Yes, there's a tag in the Git repository, and if you go and look for the Chromium source, one second, typing through. Fantastic. So it's not the repo on GitHub, it is this one here. So it's very intimidating to go navigating the Chromium source code and finding out what stuff you need. You'll see these numbers here that look a lot like Chrome releases, but ultimately this stuff is not easy for us to consume. And so the fearless leader of the Electron team, ZC Benz, has set up a repo. So he mirrors the releases that come out from the GitHub, from the Google blog. We can see 386 of them here, and he'll package up the source for every stable release. That's interesting. So here's the one at the top, Chromium 53.0. So that's probably something that we'll pull in later for evaluating the next release. We make this stuff easy for us to consume, but it's literally a starting point for everything that flows out of it. Because we need to compile the stuff for Mac, Windows, and Linux, there's various sorts of build concerns as well, but we won't go into that because you guys don't want to hear that. Cool. So when we're looking at the Chromium source repo here, I'll just pull up master to show you. This is, tree. Fantastic. So this is literally all the stuff that goes into the core of the Chrome browser. So if you look at this stuff here, you'll see like networking, PDF rendering, like this is where the magic of Chrome happens. So we can actually package this stuff up and use it elsewhere. Content module there. And there is a lovely doc inside the Chromium project explaining like what stuff is in this content library versus the Chrome itself. So the Google team will take the stuff from Chromium and they will package it up with things like extensions, spell check, form fillings and stuff. Things that aren't related to rendering of HTML page, that then sits on top and becomes like the Chrome browser. We're only really interested in the content stuff and all the stuff that the content API needs. So it's not really written here, but we call this thing Libchromium content. And the next project that we have that's related to Electron is our fork of Libchromium content. So this is, we pull in the sources from our stream of releases and we will patch Libchromium content. There are scripts inside this repo, so you can do the same thing. Just go bootstrap and build. That's the conventions that we've got. And if you have a look inside this build script here, there's this tool called Ninja. So Ninja is part of the depot tools that the Chromium team use for all their builds. So for a lot of this stuff, we will take and reuse the stuff that they do just to be consistent. Like the same stuff that they do, we get benefits from straight away. Rather than reinvent the wheel, we're just going to kind of use the same stuff that they've got there. Again, I don't expect you guys to be building this stuff, but it's not that hard to do. It does take a lot of time, however. So for the demos, I'm not going to make you, I'm not going to show you building Chromium because it takes like a good hour on my dev machine. And so coming back to the content module docs here, there's this little guy V8 at the end. So this is a big problem when building Electron because both Node and Chromium need this. This is fun in terms of how these things can get out of sync. And just make a note of that because we'll come back to it. But at the moment, the Chromium project is on a version like 2 minor builds ahead of what Node is on. So yeah, keep that in mind. Sure, thank you. So Libchromium content has a specific version file. So we bump this file, we then go off and pull down the source code for an associated release. We can then build and package that stuff up. We then put those artifacts back up, and then we can go on to the next step. To give you an idea of what that looks like, we have pull requests for these things. Crazy, open source. So the Chrome 52 release, we have just some tweaks. There's my version update. And then we have these patches. So we want to patch the Chromium source stuff, and it's literally applying a git diff. Most of the stuff is simple, switching APIs on, switching APIs off, hiding stuff. We don't intend to rewrite a whole bunch of the Chromium stuff. We just kind of want various things that we need further up the stack. The note here around the MAS build, we have support for the Mac App Store. There's also support for the Windows Store as well, which is documented, but I'm not going to cover that because I don't think we need to do anything around this, around supporting that stuff this low down. And so most of the stuff, we're just rewriting the same patches to fit the changes of source that came from upstream Chromium. So that one went away, that's excellent. And literally like, this is the boring stuff that makes the magic happen later on.
So
question?
Do you have to reapply those kind of patches every time?
Yep, yeah. And as functions move around upstream, okay, so for the recording, John was asking, so you have to reapply these patches for each release? Yes, we do. That's the annoying part, and like if you look at these, the actual details for the diff here, like the hash has changed, the lines changed, the contents changed, like that's, yes, it's tedious. But ultimately, it's not that bad. And so, oh, we did go full screen.
Is there anything they could do to make that job easier?
I've not been privy to those discussions, whether it's been thought about on our side. Most of the stuff comes down to Cheng, and so I should probably have a beer with him and discuss what his thoughts are. Where to go for 11? Cool, I'm back. So after that, just to show you a bit more magic of the scripts, we have the ability, nope, not vendor. Cool. So at the end of this build script, Cheng will go and upload these compiled bits to an S3 bucket, which we can then pull in further down the chain. So the last part of this is a little project called Brightray, if I could spell. So Brightray has one simple, boring purpose, to make it easier to host Chromium. And so there's a whole bunch of stuff under browser, which supports APIs for initializing Chromium, and then callers can just invoke that stuff. I'll talk about how we use this stuff in Electron in a bit later, but ultimately we need to then compile this guy against Libchromium content, and so the chain moves further along. So Node itself, when I was talking about V8, Node will document the version of V8 that they depend on. So the Chromium project using 5.2 at the moment. Node uses 5.0 at the moment, so this is an incompatibility. So this is why we build Node from source as well. We have our own fork of Electron, and there's some stuff in there as well, but I'll show you guys how we change this. So for the most recent release, I go into Electron, I then find the vendor node, so inside here, cool. So as part of this release, the last release, 1.32, we bumped the submodule from one tree to another. It's a little bit, it's not so well documented, so I'll just give you the cheat codes to find that. So the commit 17C9999, blah, blah, blah. So you can see here the starting point for Node was the version 6.0 release officially done upstream, and then we apply various patches on top. So again, this is little stuff that we just want to expose in Electron that Node doesn't do by default, and it's things that, again, upstream probably doesn't make sense. ASAR support is something specific to Electron, which I'll touch on in a second, but little things like changing how processes launch, because we want to embed Node in this app. We don't want to call node.exe and have some extra stuff happen. Console window. Hiding the console window when things launch, like little things like that that just make the Electron experience more polished and that we can also embed in our app. So this is where we get really, really deep with stuff. So as part of bundling Node, we will hook in and say, like, we want to compile this thing called ASAR. So even this low down, when we're building Node, we want to kind of expose stuff up to Atom. Sorry, not Atom, Electron. I'll come back to this guy in a bit because he's very, very interesting. So we're almost ready to build Electron from scratch. So I clone down the repo, I bootstrap the project, there we go, and I open up the source tree. So the interesting bits here are these folders. So Atom itself is a whole bunch of C++ code that we'll compile in on top of Chromium and Node. We have the Chromium source, which is the snapshot for stuff that we want. And then lib. So lib is a whole bunch of JavaScript APIs that become available when your app loads up. So how the stuff hangs together is what I'll touch on next, but ultimately those are the bits that are going to be of interest to you guys. Thank you, thank you. Do I have my tabs? No, it doesn't matter. And like all these other projects, there are script folders for the stuff that we need to build. There's vendor stuff. The same sort of structure flows through all of these things. And so in theory, I could come in here and bootstrap the thing, but it's going to download Libchromium content, and no one wants to watch progress bars. So I'm just going to say that I can build this. So I'm going to switch over to the Electron sample app. So this is just a sample app that was on the main Electron site. If you haven't got started with Electron at all, literally it's a 3-step thing. Clone the repo down, npm install, npm start, and you'll see hello world. Ta-da! Literally the most boring demo app that I can think of. And there's just some stuff in there around the versions of the app that I'm running. Everything is nice and boring. So I'm going to now make it a bit interesting and open up processor info. And open up Procmon. How many of you have used Procmon before? Do I need to do a quick demo? Oh, I love it. So for about 2/3 of the room put their hands up, and I'm not even going to bother explaining it. Cool. So I'm going to close that out, launch it up again. Cool, we do that. I'm just going to poke the process tree. Cool. So what happened there? Magic of npm start, launching Node, which then goes off and passes the commands all the way down until it hits electron.exe. So lots of people complain about Atom in particular doing the same thing there, launching off a number of child processes from the main process itself. So this is another bit of Chromium that we follow on the Atom side. So Chromium has the concept of this, it's so poorly named. So the browser process and the renderer process. The browser process is the main process that the app uses, and then it will spawn a number of renderer processes. If you think of the browser and tab analogy, each renderer process is associated with a tab. And so they made this decision a while ago so that if a tab crashed for whatever reason, it wouldn't bring down the whole app. We're following that in Electron because it's literally easier to do than fighting with what they've done. This will be reflected in a number of API decisions later on, but keep that in mind in distinction. Browser is main thread, renderer is the thing that gets displayed on the screen. And if you want to understand more about this, there is literally a web page on this about the Chromium project. Oh, literally a web page on the Chromium project about this. So this means, in terms of your application, when it's written in Electron, there needs to be some way to talk between the renderer process and the main process. Again, I'll show you that stuff and how that works later, but this is decisions made upstream that we then follow in Electron. Cool. A couple of quick notes here that I meant to mention before. So the benefits of having the processes isolated means that on the browser side in particular, the sandbox for the browser tab is a lot more secure. We don't really care about that much with Electron, but the greater benefit is when a process goes down that the whole application is able to keep going. So that's where the renderer terminology that flows through the rest of Electron, that comes from literally when the process launches, it knows it's a different type. Cool. So enough talk about slides. The setup of the code is what we need to look at. So inside Electron source, what is actually responsible for setting up everything? Probably the most predictable name here, browser main parts. This guy is actually part of Brightray. So what I was saying before about how Brightray is there for setting up Chromium and all this stuff, this handles all the cross-platform issues that come up. So X11, the Windows Manager for Linux, we pull in some files from that, the Windows sort of stuff. Building stuff for different platforms means that we need all the header files and stuff from these related projects. And so this is the life that we've chosen. And so ultimately we go down further, and the other real benefit of having this sort of component is that we have hooks to do stuff at the application level. So initialization, the toolkit being set up. Don't worry about the terminology here, but we get to things like the message loop. So having V8 under the hood means that there's various message loops that need to be set up. So we can do that stuff in Brightray, and then we can tailor the behavior within the application itself. Anyway, boring stuff. Atom itself, oops. Atom itself extends browser main parts into a more creatively imagined name called Atom browser main parts. So throughout the code base, you'll see mentions of Atom. We've been basically moving stuff over to Electron, but we haven't renamed everything in source. Most of the stuff is internal to Electron, and so we'll probably get to it someday, but for now, these are just legacy. It's not intended to be a branding exercise for us. So this is where the magic really kicks in. So as part of setting it up, Brightray goes off and initializes Chromium, and we initialize node bindings and atom bindings. The bindings are platform specific because of some stuff with V8, but what's interesting here is that I dive into node bindings, and then I have this, hello, referencing modules. So as part of starting up Atom browser main parts, we have a number of modules that we want to pull in. This is where the features that we have in Electron get registered, and so then we can initialize those at a later point. And like before, going further down, here we go, resources. So node bindings, again, browser thread, renderer thread. We initialize these in a slightly different way because we want to expose slightly different functionality. The renderer threads will be displaying stuff, the browser threads do not. That sort of distinction we want to make clear at build time. And anyway, you see mentions of UV, that's us configuring libuv. And if you've never seen what the libuv event loop looks like, I will give you a quick peek. Before I go further here, remember how I talked about ASAR? So we have a package that's deployed up by default with the Electron app. We then go through and run this script. So if you were doing a Node app, you would typically call Node, and then a path to a JavaScript file. We're doing that inside Electron the same. And so this init.js file has a lot of the magic around declaring everything else. Again, I haven't explained the ASR format, but I will spoil that one fairly soon. So creating the environment, declaring some extra environment variables. We go through and then load the node environment, then the message loops kick in. So just for example, I want to show you the libuv loop. Beautiful. My font size. So wait for something from libuv. If it's done, exit, otherwise poll. If it's done, exit, wake up. Literally, that is the essence of libuv, and Yeah. Yeah, but
quickly go through the events order in the event loop, please? Like whether is the poll event going to get executed before timer? So I think that was probably the perfect place to understand it, isn't it?
right, okay. We're going off script. I love this. No, it's fine. So Bud wanted me to quickly cover off the polling of events in libuv. So Control-Shift-F, let's go. Yeah, so from memory, I'm not sure where that stuff was hiding. Here we go. Nope, nope, nope. Searching, searching, searching. All right, I will come back to that, Bud. Let's cover that later. Thank you. And now I've lost my bearings. Cool. So on top of the node bindings, we have what was called the atom bindings. So atom_bindings.cc. Inside here, it's a similar sort of thing, but we're bringing in, starting to bring in methods. So get process memory info, we want to make that available to your app so you can understand what's happening and maybe help with profiling. So V8 has this concept of an isolate. It's the current running V8 environment, and so you grab that and then you start manipulating it. We can see here a couple of examples of, by hooking into a method called getWorkingSize, under the hood, we'll call this getWorkingSize method. Very, very one-to-one in terms of stuff, but this becomes a way for us to expose functionality to apps themselves. And so we get down to the end after all these little methods. There's our libuv constructor, and then we have this thing called bind2. So these methods, we'll actually find those ones in the JS side in a little bit. But ultimately, just keep in mind, again, this gives us the ability to compile in platform-specific stuff and also expose the versioning info. Cool. So where does this stuff appear? Off of process. So the very core of Node, the running process, we see all this stuff. So there's my get process memory info, there's my get system memory info. If I poke the methods there, that's not what I want. Get system memory info. It's a function. It's native code under the hood. But this is where you find this stuff when your application runs up. So if I go process.versions. So in our Atom library, we looked for the versions property, and then we added in a couple more of our own. And you can see those here. The Atom shell, the Chrome version. All this stuff is where, this is how we expose stuff to the app itself. Yep, so we got a front office there. Fantastic. So coming back to node bindings, we declared a bunch of stuff at the top of this file with that reference module macro. We see browser again. We see common again. This is, again, following kind of like the same consistent structure of browser, renderer, common. These things map to source files up here. So app itself is not of interest to us. We have browser/API. So the features that we're looking for are all under the type of process that we're running and then API. So I do love the good app example because that's at the top. So Atom browser app becomes browser API, Atom API app. So inside here, a similar sort of setup, but because we're no longer dealing with the libuv bindings, we're more just defining functionality and attaching it to wherever we want. So still some platform-specific stuff, mapping things from V8, blah, 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 blah. Let's just go straight down to the bottom of the file, because otherwise we'll be here all day. Cool. So at the bottom here, there's our Atom browser app name. And so this is how Node lets you register native modules. And so you say, I want to register with this name, and I want this method to run. So like before, we go and grab the isolate for the current V8 environment. In this case here, we have .app, just a whole bunch of other extra options there. but it's not off my process. It's somewhere else. And so what I'm going to do next is show you guys where that stuff is organized and why things are where they are. And so the last thing I glossed over before was our little friend ASAR. So ASAR is a little project that came from a need for us to package things. And I gather you people know about the tar archiving format. You guys I don't see neckbeards in the crowd, but that's fine. Very much tar inspired, but ultimately it's a read-only archive. We want to make it easy to pull files out within your app, but ultimately just have one file for the ease of deployment. And so there's a library on NPM that you can use for creating your own packages, but ultimately we bake this thing into Node because we believe it simplifies a lot around the deployment. That's going to be coming up, but ultimately, don't worry about that. It's just another repo on GitHub that we use. Cool. So the demo app itself. Just going to open up the demo project in Atom and just show you guys the various parts that make up the app. It's literally a minimal thing that you need. Cool, there we go. Possibly. Fantastic. All right, so the parts that are of interest to Electron itself are the main JavaScript file, which is the entry point to the app, the index file, something to show for the end user, and the JSON file. So the JSON file, you can specify the main entry point to the app. I think by default it's going to choose index.js if you don't. We have some scripts to run stuff up, but ultimately the bit that, come on, scroll. There we go. So rather than having to build Electron from scratch like you would with other native dependencies in Node, we ship a pre-built version. So what this does at install time is that it downloads the version that you need rather than having to pre-compile it. The main.js file, again, fairly simple, just there to kind of do the hello world basis. But it looks very much like a Node app. So we require a module. We have a look at some of the APIs that are available. We scroll further down. No, stupid cursor. We listen for events that gets raised, and we do stuff about it. It's all very conventional. If you've ever used the event emitter stuff in Node, like this API should be familiar. Cool. So I'm just going to drill down into how this magic works, because at the moment I don't actually have an Electron module defined in my list. I don't even have any actual dependencies. No, that's not my one. This dependency here, Electron prebuild, is a dev dependency. Where is this stuff? So switching back to the Atom source. You remember how I mentioned init.js before? Atom bindings. Nope, I'm just going to do no bindings. Beautiful. So this init.js file is responsible for registering the modules that the application needs. Again, because it can be browser or renderer, there's actually two different files that live in the source code. And to ensure it's been packaged up at runtime, there's that stuff there. But all this stuff is under lib. So lib, in this case here, let's go with browser. And let's go with init.js. Let's pop this baby open. So we have some common functionality to both, but then we dive into the module global paths. Hang on a sec, what's this guy? So initializing Electron means that we will actually define some exported APIs. Again, the stuff follows the convention of stuff being under API. So the example I'm going to look at, API exports Electron.js. So we have one for the browser thread, we have one for the browser process, we have one for the renderer process, and this Electron.js file is actually kind of boring. So we pull out the common exports, we then add some extra exports on top. each of these files is associated, each of these properties is associated with a file further up. Again, requiring stuff, pulling stuff in, just composing everything together on the client side. I say client side because JS side. And these files here, I'll just look at app again because that's a good example. Just regular JavaScript files. The magic that comes up from atom binding, I'll explain in a bit, because that's then going back into some native code. But ultimately, this stuff is just JavaScript code, which we then make available to your apps, so as part of the requiring step. Very simple, very straight up. Yeah, so that's where all this stuff is, and if you want to start poking what APIs are available, that's cool. And to show that there is no secret trick here, I'm just going to launch the app again. Cool. So there's the features that are available. Unfortunately, app isn't there. So I was in the browser thread here earlier. That's possibly there. But this is me actually hitting the renderer process. So when you run up an Electron app, your Chrome DevTools, if you pop it up for your browser window, it's going to be associated with the renderer thread. So the renderer process has more limited functionality available than the browser process. And so if I go require electron.app, it's undefined. And so this is where the separation is between both functionality and access to resources. So back in my app.js file, I have this thing called atom binding. Where was this guy? Oh, beautiful. So atom binding, oh hell, I'll just go straight to the common one. So shortcut, it's under lib common. The demo gods don't like me. So this is going to be under lib common API, no, init.js, as soon as it comes good, of course. Beautiful. So process.atom binding hooks into the existing way for resolving bindings in Node. Again, same browser, same trick of like, do we have a browser process or a renderer process version? If we don't, try the common version. This is how the JS files are getting access to features that are defined in native modules. And now I'm indexing files again. I love the demo gods today. So yeah, so the fallback behavior for looking for the common process, the common functionality versus the browser-specific, the process-specific behavior, yeah, we're hijacking what Node does initially. So when we were registering stuff in the Node bindings, we can then go and resolve it here. And I'll just go find the file myself. Thank you, Atom. Under source. Beautiful. So. Cool. So if you're curious about understanding what the binding behavior does, we roll through the current environment. We try and find a module that matches the name, literally like key value lookup for stuff. What's interesting about this is that it's a void returning method, but if it's successful, it'll set the return value. Very esoteric C++ stuff, but it's V8, so we're not going to argue with V8. We get down to the end here. Yeah, so we're leveraging that same stuff in Electron to do features in the same way. Again, being consistent. So one more thing I was going to do here. Cool. And like before when we were setting up stuff in Electron, Node itself attaches methods to the running process, and that's the magic for binding. Cool. So I talked about ASAR, at least from a conceptual perspective. What I'm going to do here is flick back to the PR and show you guys how we're doing this stuff. So from memory, we're doing process.binding, going to load a module from the Electron side, and we're going to call a method on it. Jump up to Atom, common, ASAR, sorry, no, API, got to follow the rules. Atom API asar.cc. So that's the module there. And inside here, there's some code for getting things set up. There's some code for defining methods on objects that return. We get down to the very end here. I'll just go find the method because I'm impatient. Cool. So here's our method in ASAR support. There it is being defined, being registered by the module. Again, like now the stuff is available at the Node runtime, which then calls all the way up, back up to Atom to register the stuff. It's a little bit of a crazy, hairy architecture, but all we're doing in here is just passing it a script and compiling some, to V8 to compile some stuff. It's totally fine. The script is related to ASAR init.js. Who knows the file system module in Node? We are kind of, hey, they said it here, monkey patching FS to add in ASAR support. So when you pass in a URL that has an ASAR extension in it, we're like, all right, cool, we got this. And so this is just the setup for that. We're literally hijacking process.binding to then change how FS module works. If we want to find that stuff, it's going to be, I'll put it, So the ASAR JavaScript module, there we go. We're loading in some of the native stuff, path.util. When I found the stuff, I was kind of like half crying and half laughing at myself. Beautiful there. So what I want to find is one of these methods. No, not found. So exports, this is going to give me something. So exports.wrap FS with ASAR. So this is where we're getting into what is happening here. So all the relevant methods on the FS module, we will wrap, essentially. So else statting a file synchronously. We grab the original version and hold a reference to it. We then write our own version that has ASAR support. If it's successful there, we'll go through and run it. Otherwise, we'll go and use the default behavior. This is where I kind of was feeling a bit uncomfortable, but ultimately, most people don't notice this stuff. It's just transparently there in the background, and things just work. Okay, so we've talked about hot patching of Node modules at runtime. We've talked about the processes of sharing stuff with native and exposing it in JS. Let's go back to my sample. So in here, in my main JS, so we've found out how to get to our app property. Of course, this is on the browser process rather than the renderer process. We saw that fail before. We then have things like browser window. So coming back to my Electron exports. So browser.app, auto updater, browser window. Here we go. So the contents of this guy are in a file, I can't even pronounce words today, creatively called browser-window.js. So like before, we get access to the bindings for window. We then add a bunch of functionality. So like before, we can create a browser window. There's also just a bunch of static methods further down. But what's interesting here is the hook for web contents. So Web Contents API is kind of like the raw access to Chromium. If you want to hook into events on that, you do some stuff there. This little example here is if a new window pops up in the background sort of thing, actually hook into it and actually do some behavior with it. So for things like making a page automatically pop up, like we need to do some of that stuff in Electron to make it actually work. There are a whole bunch of custom events that Electron surfaces around managing stuff. The Electron space prefix, you shouldn't be just opting in for those in your app, but they're there if you're definitely curious. So switching back to where was my init method? Cool. So this is the little example of initializing a browser window. If you're on OS X, setting the application menu. If you're not on OS X, setting the application menu. And then before, if you have a pop-up window that appears, doing some stuff with it. The fun stuff comes. Let me switch back. So browser window, we go new up a browser window. We then have various events on these browser windows. So IPC kind of pervades a whole bunch of the Electron stuff. It's magic strings, but it's fairly easy to then hook into stuff behind the scenes. So if you go and Google for emit, just for reference, I'm searching for this little magic string in all the C code. Cool. So emit is ultimately where the stuff comes in from the native code, and there is just, this is the easiest way for native code and JS code to just basically pass messages around. Most of this, I'm doing good today with the demo gods. Yes, so this stuff there, this is definitely how the renderer thread can communicate back to the main thread, and if you're looking at the example code from before, this is how the events flow through from, when is it appropriate for me to raise a window, to pop a window, when is it appropriate for me to close, like the IPC stuff is based on what's, at least in the event emitter side on the node bits. This stuff is, yeah. And thankfully, I'm having a lovely day with the demo gods. No, I'm good. I'm going to ignore you. So coming back to, I'm going to solve Bud's little question about the polling of events in libuv and pray that I actually have something that works. Any questions while I also pray?
Actually, I'll clarify the question because
Yeah.
the bit that got me interested in that was that when you start the node process, right, it starts the event loop.
Mm-hmm.
So in Electron world, it seems like Electron is the one who sets up the event loop,
Mm-hmm.
right? So the event loop kind of decides what order the timer callbacks, IO callbacks, and everything is executed, right? Is
Yeah.
that order different from node implementation? Because I've recently come across some forums where if you use, like, for example,
Yeah.
next stick,
Mm.
as opposed to what is it called, set immediate or set timeout
Yep.
zero.
Yeah.
Behavior is completely different under the node.
That is a good question.
So
Okay, let me recover my dev environment. Yeah, so in the atom bindings, we were just calling poll events. Like, that is then probably going to the default implementation of that. I don't know why we would do things differently. It seems crazy. So anyway, so just for curiosity, can you say again what you were seeing versus what you were expecting to see? So you were talking about things like set timeout and set immediate.
if you set timeout, so let's say, for example, if you, the default node order, if I remember correctly, it runs the timer callbacks first, and then it runs IO callbacks and the immediate functions, the set immediate functions.
Mm-hmm. Yeah.
But if you use set timeout with 0 and set immediate in your main module, it's not in a callback, then the order is completely arbitrary for some reason.
Yeah.
If you guys are setting up the order in the event loop, then you might have more unpredictable behavior unless you go and try to understand.
Yeah, so like skimming the code here, like it mentions being implemented by derived classes, and I can't find an example of that here, so I don't, but I'd love to understand more because I don't know enough about libuv's internals to kind of specify either way.
That's right. I could just start reading through this. This is a good starting.
Yeah, so no, I don't have a good answer for the polling event stuff, but I don't think we will do anything dumb.
That makes sense.
Cool, yeah. Any other questions at this point?
Are you going to talk about node chip or integration with other system custom implementations?
What sort of integration were you thinking of?
Existing code, legacy code.
Yep. So you could do the same thing as we're doing, is like register a node module, declare it, the examples that we have here. So if you're interested in doing native, not app, sorry, browser, API, I'll get here, sorry, Atom API. So if you're interested in doing the same thing here, this magic, the node module context aware built-in, this is how you would declare some native functionality. So you could then do the same trick that we're doing and register some JS files as well to expose that stuff. You could absolutely do that same stuff if you wanted to in an Electron app. How that stuff would get hooked in, I'm not 100% sure. I've already discussed with someone today about the ability to build Electron from scratch for doing that stuff. I don't have a good example of doing that stuff with vanilla Electron, but if you want, you can chase me up after this and I can do some digging. So for those of you who aren't that familiar with this API, there is a lovely blog post floating around. It was called this. Cool. So ages and ages and ages ago, Node has had a problem with the context for these things. So in the release notes here, the event loop here would be a weird sort of context when things were executing. Ultimately, they worked out that this is just the API that module authors should use, and so like just use that and everything's fine. Of course, that was like Node 0.12, so that was 2014. Cool. So that stuff's been there for a while, but ultimately, this is just how all the Node modules will declare their external code. Cool. How am I doing for time? I've got about 5 minutes here. Any other thoughts? Jason, you look.
Yeah, so you hook in with C++ bindings on the Chromium. Did you do any wrappers to make that easier?
So that would be the Brightray project. So Brightray is so this is still C++ code hosting Chromium. If you wanted to do that stuff yourself, this is the project that I'd use. There is an example project here. Imagine it'll be called Brightray example. So this is a little demo app that we've done to show about the hosting side. Oops. Yeah, I reckon if you want to understand how Brightray could be used, I'd have a look at that one. I think it's still C++, but yeah, that's the big, we mostly do C++ stuff because we know it's going to be cross-platform, with a little bit of compilation magic, of course. Cool. All right, yeah, well, I'm going to hang around. If some people want to hit me up for stickers after, come say hi. Otherwise, yeah, thank you for your time.